In this video, I am going to explain how the bullet train or magnetically levitated trains are going to work with the basic construction, with the basic working principle, and how much levitation has been done from the tracks, and what is the main basic difference between the ordinary trains and these magnetically levitated trains. What is the basic principles like Lenz's law, Faraday's law, or basically, we can say the magnetically levitated trains can be working with basic two concepts. The levitation can be possible by using two concepts. The first concept is electromagnetic suspension, and the second concept is electrodynamic suspension. What is electromagnetic suspension? This is simply like a north and south pole will attract each other, or north and north pole will repel each other. This concept will be used all the time whenever, even at the initial momentum on the tracks, the wheels will be disappeared and the magnetic levitation will come into picture, and after attaining some speed it will reaches levitation and reaches higher speeds like 500 kilometers per hour or 600 kilometers per hour or 430 miles per hour. In this, we are going to explain what is the basic concept of electron dynamic suspension. By using this electrodynamic suspension concept, finally at the end of this video, we are able to know what is what is the concept behind how to stop bullet trains, how levitation takes place, importance of superconductors in these bullet trains, how bullet train is different from ordinary trains. All details of these trains will come in clear into the picture after at the end of the video. The bullet train or magnetically levitated train works on the basic principles of three laws. First one is Lenz's law, second one is Ampere circuital law, third one is superconductivity. All these laws are interlinked each other for making levitation successful to raise the train from 1 centimeter above from the tracks, that is called levitation, can be done by using these three laws. Once we see the basic law of Lenz's law definition, Lenz's law states that the current induced in a circuit due to change in a magnetic field is directed to opposite the change in flux and to exert a mechanical force which opposes the motion. This will be clearly explained with a basic example as of now we will take in place. The Lenz's law demonstration will be seen by using this experiment. Let us carefully observe what's happening in this. Where the man is carrying one strong magnetic field, strong magnetic bar, and this is the conductor. See what he's doing is the man is just moving the highly strong magnetic field towards the conductor and away from the conductor and observing the movement of the conductor. Now this can be clearly explained like this. Here, suppose assume that it is a strong magnetic field which is denoted by north pole. Whenever this north pole is moving towards the conductor, what happens means that because of the magnetic field lines will be cut by this conductor. This conductor will induce some current in such a manner that it will generate a north pole so that it will both will repel each other. What I want to say is the motion of the strong magnetic bar has to be opposed, so that how it can be so opposed means in this case if both are north poles, then the motion of the conductors can be opposed as shown in figure. So whenever this strong magnetic field is moving towards this conductor, this induces a current in such a manner it becomes the north pole. See here, Whenever the conductor is entering towards this, the force being experienced. Whenever that is coming outside like this, suppose the conductor is going away from this, what happens? The conductor is going in this direction. So in order to oppose this motion of this direction, here suppose assume this is a north pole, then in order to oppose moving away from this in this direction, second concept is Ampere's circuital law. Suppose here whenever to say that depending upon the current direction, we are able to monitor the speed of the bullet train or magnetically levitated train. The speed can be controlled. Why? Because north and south pole will attract each other and north and north will repel each other. By using this concept, we are able to by using this concept, we are able to either accelerate the train or loco, or we are able to decelerate the loco. For example, if this is a positive terminal, if this is a negative terminal, then this windings, according to these windings, the current travels in this direction. So this is acts as south pole and this acts as north pole. So this can be altered just simply by reversing the current as now. Now the direction of the current can be altered simply by making this polarity as positive, this making as the polarity as positive and this polarity as negative, then obviously it becomes south pole and it becomes north pole, and the current direction is like this. That means same circuit, same thing, just by the reversal of the direction of current, we convert them as north pole into south pole or south pole into north pole, vice versa, as we like it. This is the basic concept number 2 that mainly used in the bullet trains or magnetically levitated trains. The third concept is superconductors. Superconductors are nothing but when the temperature is cooled down below certain temperature called as critical temperature, then the given material or superconductors gives you the zero resistance property or infinite conductivity property as shown here. This is the superconducting material, and this is the coolant. Here coolant has been given so that, like nitrogen, liquid nitrogen, in order to reduce the temperature of the superconductor below critical temperature called Tc, then this superconducting material exhibits the properties of zero resistance or infinite conductivity so that continuous magnetic lines can be developed. Now see the condition of this conductor which is placed on the superconductor. See, simply after cooling down to certain critical temperature, then the material levitates, as seen, clearly see. This is the basic concept that has been used in the superconductivity of the magnetically levitated trains. The train will levitate like that. Just now, as we have seen, the levitation concept, the levitation same concept will be used here for raising 1 centimeter upwards of the above compartment from the tracks as shown here. See here, levitation electromagnet, undercarriage, guidance rail, this guidance electromagnet. By using Lenz's law, this north pole and south pole will be attracting if there is a fast movement of train. Suppose initially on the tracks the train is moving with ordinary velocity, but after attaining some certain limit that undergoes magnetic levitation by using the Lenz's law. Why? Because as I told earlier, there will be a lot of magnetic lines being cut by the conductor, as I explained earlier. That same concept will be clearly undergoing here. See here, this levitation guided coils, these coils makes the train to be levitated from the tracks, and this also comes with the propulsion coils. These propulsion coils will make use of the controlling the direction of the train from one place to another. See, the direction of the motion of the train can be seen here. The direction of motion of the train can be seen here. This north pole will be attracting towards south pole, and north pole will be repelling towards north pole, so there is a forward motion. And this how this variation of poles can be achieved means the variation of poles is achieved by simply by using the Ampere's law, or by the direction of current of by varying the direction of current. Then we can easily change the north pole into south pole and south pole into north pole, whichever we require. Suppose if we want to decelerate the loco means simply change the direction of the current in those coils in such a manner that the train will not move further, or it will decelerate according to the situation. This strong magnetic fields or levitations is possible by using superconductors. How the superconductors working means whenever the superconducting material is reduced below the temperature, certain temperature, then it exhibits Meissner effect. That will come into the next video. Meissner effect. By using the Meissner effect, we can produce the magnetic field lines, so the strong magnetics can be developed and levitation is possible, as clearly explained in the previous slides. That's all for today, friends. I hope you understood how the magnetically levitated train has been lifted up and going forward and backward. Any doubts are there means please comment in the comment section. Please like and share my video, and any suggestions or anything is required means please give me some advices. Thank you, friends.